The second one is looking at what happens when we manipulate a distribution or we combine a distribution with other distributions. So, I think it's probably first to have a reasonable idea conceptually what standard deviation is. Standard deviation, both with probability distributions and regular statistics, is a measure of how far each point deviates from the mean. So a standard deviation is literally the average deviation, meaning what is the average amount that each point lands away from the height. So if you think about it, so not height, lands away from the mean. So if you think about this class, the mean in this class might well be 172 centimeters high, and it's entirely possible that no one in the class is 172. Some of you are slightly above, some of you are slightly below. None of you land on the mean. Some of you might be 1 centimeter below, and some of you might be 1 centimeter above. In this case here, the standard deviation of our class of 3 people is, well, there's 3 people, there's 2 deviations, so the standard deviation is like approximately 2/3. So there is an average amount of 2/3 away from the center. One is 0 away, one is 1 away, and the other is 1 away. And as we add in more data points, if they spread further, the standard amount of spread, or the average amount of spread, will increase. In probability, the way we calculate standard deviation is like this. Most of the time, 99% of the time, you'll do it into a calculator. Today we're going to do it by hand once, just so you can experience the joy of doing this calculation by hand. And in theory, you might be asked to do it by hand, but in general, it's largely a calculator question. Variance is the standard deviation squared. This is actually the variance formula. That's variance equals this. We get the standard deviation by square rooting both sides. So, by hand, we need to, before we start using this formula, find the mean. So, you might remember from yesterday that the mean is the sum of all xi pi. Or in this case, it is 0 times 0.1 plus 1 times 0.15 plus 2 times 0.45 plus 3 times 0.25 plus 4 times 0.05. Bring it all together. What is that? That's 0.15 plus 0.9 plus 0.75 plus 0.2. Oh, 9, 1.8, 2. That would be nice. Is the average 2? Could be. Let's pretend I've done the maths right and the average is 2, because that makes the numbers nice and easy to work with. Alright, standard or variance is the sum of all each outcome subtract the mean squared. So that is the gap between each outcome and the mean, squaring it, multiplying it by the probability of that outcome occurring. So in this case, it is 0, which is the first outcome, subtract the mean, squared, multiplied by the probability of that occurring, and then plus. The second outcome, 1 subtract the mean, squared, multiplied by the probability of that occurring, plus the third outcome, multiplied by, subtract the mean, squared, multiplied by the probability of it occurring, and so on. variance squared equals some number. I'm confident you can all put that in your calculator if you're forced to. That's variance, and then if you wanted standard deviation is just the square root of whatever was above. A few little features of the formula that maybe you can appreciate. If you're working out the difference between two numbers, say this and the difference of the mean, it's entirely possible to come out with negatives. So here and here will come out with a negative. But of course, then the gaps on this side of the mean will kind of, if they were left as negatives, will cancel out the gaps on this side of the mean that come as positives. So the workaround for this is to square the gap. Once we square the gap, it makes them all positive. It means that every time there is a gap between the mean and one of the points, it comes out as positive, which is why this appears in the formula, which is neat. So it's like the formula's way of getting a positive measurement from this each time.
So you could just not square any of it.
Well, but then these would come. Then it wouldn't. If they're all positive, you could probably get away with it.
Yeah.
Yes, but because they're not.
Yeah. Sure.
Yeah, and they're not guaranteed to be.
By definition, that symbol means standard deviation.
That's standard deviation.
Yeah.
Yeah, and that's variance.
Yeah.
Yeah. Yeah. And it's this on your calculator also.
Yeah. We usually ask for variance or standard deviation.
Almost always ask for standard deviation. Variance is almost never used.
Yeah.
Yeah.
What is variance represent? It's just
Standard deviation squared.
that's the only. Yeah. Okay.
Yeah.
Great.
Yeah. So the next page has a sort of set of formula, and this will be the sort of thing you put on your cheat sheet. Mean, standard deviation, variance, standard deviation. Notice there is an alternative formula that also works for standard deviation. I'm not sure where this would be better. The only time I can see it being better is if they tell you the standard deviation and ask you to solve for the mean. You can imagine here solving for the mean or solving the average would be really hard because the sigma throws in lots of means. Here, if you're solving for the mean, there's only one lot of mean squared and the sigma doesn't generate any more means. Sorry. So if you're solving for mean, use this formula. Otherwise, there's not a lot of difference between the two of them. All right. We're not going to do this entire thing, but it was just a good recap because we touched on some of these questions yesterday. Find the value of k. So they sum to 1. They make 0.4. Therefore, you can say that 4k equals 0.6. We're sort of happy with that. Divide both sides by 4. K equals 0.6 over 4. That's a bit ugly. I mean, you can work with it, but it's not fantastic. I would multiply top and bottom by 10 and then simplify.
Where's the 4K coming from?
Ah, sorry. There's 3 of them there and 1 of them there. Yeah, so the 4K. All right, mode of the distribution. Is 3k bigger than 0.35? Yes, it is, isn't it? Yeah. Because 3 on 20 is 0.15, so 3k is 0.45. The mode, therefore, is 20. Yeah? Are we happy that, given we just did a similar problem, we could find the mean and standard deviation? Probably. Did you want me to do it on the calculator, just sort of jog memories of how to do it on the calculator? All right, let's grab the calculator. Mode, it's the most likely to occur. So in this case, the mode is 20 because it's the most likely to occur. 2, 4, 10, 20.
You knew what I mean when I said it's a bigger probability.
Alright, and then chuck in the probabilities of each of them. So we are 3 on 20, 0.05, 0.35, 9 on 20.
Yeah.
Couple months, Captain.
Alright, so once you throw in the distribution, click set just to double check. It should be list 1, list 2, that was left over from yesterday. And then if you click 1 var, it will show you the mean and the standard deviation, so 6.95.
Why is mine different?
One's wanted.
Yeah, I got 6.88.
Because I wrote 3 there, and it's a 4.
Mentos?
6.88.
Mentos?
If there's one left. There is. Someone put an empty wrapper back in my book.
Damn.
Ah, there is one. In your own.
Thank you. I'll show you.
Alrighty. Alright. Can you give everybody a dice, please?
What button do we use to calculate the?
Here. One vase, F1 will give you the.